Hi, welcome to the lesson about the powers of whole numbers. In mathematics, there will be instances where a number is multiplied by itself repeatedly. Oftentimes, it is best that these expressions are represented using exponents for simplicity. For example, say we have this expression 2 times 2 times 2 times 2. This can be represented using exponents. Using exponents, the expression can be written with the base number and a number written on the upper right side of the base number called the exponent. In this example, 2 is the base, and 4 is the exponent. The base is the number that is to be multiplied by itself. The exponent is the number of times the base is to be multiplied by itself. This expression is read as 2 to the 4th power or the 4th power of 2. If we are to evaluate 2 to the 4th power, 2 to the 4th power is equal to 2 times 2 times 2 times 2. And this is equal to 16. There are also frequently used powers. For example, 3 to the 2nd power. The 2nd power is frequently used because it is used in computing the area of a square. And because it is used to compute the area of a square, the expression 3 to the 2nd power can also be read as 3 squared. If we are to evaluate 3 squared is equal to 3 times 3. And this is equal to 9. Another frequently used power is the 3rd power. The 3rd power is frequently used because it is used in computing the volume of a cube. For example, 5 to the 3rd power describes the volume of a cube with a base length, a base width, and a height of 5 units each. And because it is used to compute the volume of a cube, the expression 5 to the 3rd power can also be read as 5 cubed. If we are to evaluate 5 cubed is equal to 5 times 5 times 5. And this is equal to 125. Let us have more examples. 1 squared. What is the equivalent of 1 squared? Let's evaluate. 1 squared equals 1 times 1. And this is equal to 1. Next example. 1 to the 4th power. 1 to the 4th power equals 1 times 1 times 1 times 1. And this is equal to 1. What have you noticed? 1 to any power is equal to 1. Next examples. 3 to the 1st power. What is this equal to? 3 to the 1st power equals 3. Next. 0 to the 1st power. What is this equal to? 0 to the 1st power equals 0. What have you noticed? A number to the 1st power is equal to the number. Next examples. 0 squared. What is this equal to? 0 squared equals 0 times 0 equals 0. Next. 0 to the 4th power. 0 to the 4th power equals 0 times 0 times 0 times 0 equals 0. From these examples, we can say therefore that 0 to any non-zero power is equal to 0. Let us express the following using exponents. 6 times 6 times 6 times 6 times 6 times 6. How many factors or how many times 6 is being multiplied by itself? The answer is 6 times. The expression using exponents is therefore 6 to the 6th power. Next. 7 times 7 times 7 times 7 times 7. How many factors or how many times 7 is being multiplied by itself? The answer is 5 times. The expression using exponents is therefore 7 to the 5th power. Next, 9 times 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 9. How many factors or how many times 9 is being multiplied by itself? The answer is 8 times. The expression using exponents is therefore 9 to the 8th power. Last example. 10 times 10 times 10 times 10 times 10 times 10 times 10. How many factors or how many times 10 is being multiplied by itself? The answer is 7 times. The expression using exponents is therefore 10 to the 7th power. Welcome to Hippocampus Learning Videos. If you are enjoying the Hippocampus Learning videos, please give us a like, subscribe, and hit that notification bell so you can be notified when new learning videos are added to the channel. Hippocampus ETV is also on Patreon. Please check it out. Happy learning! That covers the lesson about the powers of whole numbers. This lesson is more of an introduction to exponents, and there will be more to come. The next lessons will be about the laws of exponents. In those lessons, the laws in manipulating expressions involving exponents will be discussed. Those lessons will cover and include the process of adding, subtracting, multiplying, and dividing exponential expressions following the laws of exponents. Those lessons will be very interesting and fun. Thank you for joining us in learning this lesson. We hope you had fun and learned a lot. Please continue studying and continue watching these learning videos. See you in the next lesson. Happy learning!